Okay, so we are going to continue on with the Born Haber cycle. There's another way we can get at that energy using the exact same equations. And it's an application of something we call Hess's law, which we've not talked about yet, and we won't talk about for a few more chapters, unfortunately. But if you have your notes from the Born Haber cycle, I would recommend getting those out so you can follow along with me, because I'm going to be using all of the reactions and all of the energies that I used before. Okay, so the first step we talked about was the sublimation of sodium. Okay, so I want to write that out. Whoa. So Na solid went to Na gas. Okay. And over here, I'm going to write the energies. I'm just going to write them all in kilojoules. I'm not going to write that over and over again, though. 107.3. Okay. Sorry about that. Next up, we had the bond dissociation. Oh, that's not what we had next, was it? Next up, we had the ionization energy. For sodium. And that was simply removing that electron. So we had Na gas, giving us Na plus gas plus an electron. Okay, next up, we had the bond dissociation energy. I'm just going to abbreviate energy as E. And that was for chlorine. Okay, and that was 1/2 Cl2 gas, Cl2 gas, giving us Cl gas. Oops, I forgot the energy for the ionization energy. And that was 495.8. And this one was 122 kilojoules. Okay. Next up, we had the electron affinity. For chlorine. And that was chlorine gas plus an electron gives us Cl minus gas. And energy there was negative 348.6. Okay. Last but not least, if we add in here our lattice energy step, we have Na plus gas plus Cl minus gas going to NaCl solid. And that was negative 787. Now, I want to just take all of these values and equations and I want to add them. Okay? I'm going to add them all up just like you can do in algebra. You can add 3, 4, 5 different equations, whatever you want. I'm also going to add all of the energies for these. However, it's a lot of stuff to write down. And if you'll notice, a lot of these things like Na gas appears in 2 different equations and it appears on opposite sides. So what we can do is we can actually go through and we can cross out things that appear on both sides of the equation. Sorry. Okay, there we go. I'm trying to zoom in. So if you notice Na solid, if we look, Na solid does not appear anywhere else in our equation. So I'm going to just go ahead and circle that in the highlighter. Na gas appears on opposite sides of these equations, so I'm going to cancel it out. Na plus gas, do we see Na plus gas anywhere else? If we look, we see it right here on opposite sides, so I can cancel that out. What about that electron? Does that electron appear on opposite sides? Absolutely. There it is. Cancel it out. What about the 1/2 Cl2 gas? No, it does not appear anywhere else, so I'm going to circle that. Cl gas, does that appear on both sides of these equations? Absolutely, right there. And then Cl minus gas, yep, there and there. And then we have NaCl solid. Okay, so if I take everything that from above that is circled and write it back down here, Na solid plus 1/2 Cl2 gas gives us NaCl solid. And it turns out if I add all these up, 107 plus 495 plus 122 minus 348 minus 787, what do I get? I get the overall energy change for this reaction. Okay, so that's another way to look at the Born Haber cycle. Like I said, it's an application of Hess's law. We'll get to that a little bit later on. And the key here is if we're missing any one of these steps, say we're missing this step here. Well, just through algebra, we can find it. We can add all the other ones up and find this one. Okay. So anyway, that's the Born Haber cycle. I know it's a difficult topic, so go ahead and send me some emails on that or post to the forum, please.